Hi, guys, and welcome back to another episode of Women in Math and STEM, where our mission is to reach out to as many professionals, aspiring professionals, students, whatever you name it. We try to reach out to them, who essentially support the initiative of bringing more women and young girls into the STEM field. So, with that being said, as always, feel free to open up the description or transcript to better follow along, and I hope you enjoyed this episode. Hello, and thank you so much for coming to the call today and talking with me. Just to sort of start off, do you mind briefly introducing yourself as well as sort of walking us through your journey to sort of get you where you are today?
Yeah, definitely. So my name is Sophie. I'm a fourth year math and physics student at the University of Toronto at their St. George campus. So as I mentioned, I'm doing a major in physics, a minor in math, a minor in science, technology, and society, and a business certificate on the side. So how did I get into math and physics at the university level? Um, it honestly kind of started in high school. When you're in high school, you're just trying to, stay afloat and try to get the best grades possible. At such a young age, it's very difficult to know what you want to do. And so that was me. I was trying to, get A's in all my classes and be the best student possible, but I didn't really enjoy a lot of the things I was doing. I was just kind of, going through my academic career, my high school career, and just trying to figure things out one by one. So then by grade 11 and 12, when subjects start to split into like biology and chemistry and physics, I ended up taking all of those courses. So I had all three sciences, biochem and physics, and then I had calculus and functions. So it was a very, very heavy year. Um, but ultimately, that really pushed me to figure out what I wanted to do. And biology and chemistry are very interesting and useful subjects, but I found that I was most interested in math and physics. Um, it's not something that people understand right away, but it was a subject that I really enjoyed learning and I enjoyed the challenges that came with it. And I also happen to be really good at it as well. So all those factors ultimately decided that, I kind of want to pursue math and physics in university and see where it takes me. So that's where I am today.
I think you also mentioned you're studying science, like, and technology and society, as well as
Yes.
business. I was just wondering what sort of got you into like other areas of study, and it sounds like a lot, like sort of how you balance all of that and like all of your interests.
Yeah, definitely. So, math and physics on its own is quite heavy in the technical aspect. There's just a lot of analysis, a lot of numbers, graphing, statistics, all that good stuff. But now, how do I actually combine such a heavy background with sort of understanding how I can use it in the real world? And so that's where I figured out I want to do a minor in science, technology, and society because as in the name itself, you are learning how to implement technology in society. Like, where exactly will I be able to implement math and physics? Where does that go? Right? Because you can only be so book smart, but then when you actually get into the real world, that's the biggest challenge. Um, and with the business fundamental certificate, for me, I wanted to try and tap into as many different areas as I could with my degree. So math and physics is on one end of the spectrum, but how can I also make sure that I'm still, competent in other areas? So that business also helps you understand how to take your technical background into the world as well. And business is everywhere, right? It really doesn't matter what you're going to do in life. You'll always end up doing something related to business. I also kind of want to do something entrepreneurial, maybe. That's, you know, something I'm really open to as well. So yeah, just having a good foundation of business can can really take you far, I think.
I think you also mentioned that math and physics are very like technical fields. So I was just wondering like what do you sort of do when you encounter a very difficult problem that's very hard to solve? And sort of, is there any problem that immediately comes to mind that took you a long time and you finally were able to solve and that like you're very proud of?
Yeah. So to answer the first part of that question, sorry, when I approach solving problems creatively, I like to think about different angles and what is contributing to this problem. So sometimes stepping back to see the bigger picture, breaking it down into smaller and more manageable parts can also help. This is directly related to physics because we get a lot of big, like 10, 12 step problems. So it's kind of a lot thrown at you all at once. So it's up to you to really break it down step by step so that you can do it. Um, I have an example. It's a little technical, but I'll try my best to keep it as understandable as possible. So, in one of my physics labs, we were designing an experiment to measure the acceleration of a using a pendulum so figuring out the acceleration due to gravity using a pendulum. Now, the traditional method would simply involve calculating different oscillation periods, but because the environment we had, it had a lot of air resistance, and that was really affecting our data. So instead of sticking with such a standard approach, I decided to get creative, which is really difficult in physics, but I really had to try hard here. So we developed a solution to adjust the model and to account for the air resistance. So we used differential equations that was able to incorporate both the pendulum's motion and the drag force of air. And then we used Python and developed a numerical simulation to fit that in our experimental data. So this approach was more accurate. It took into account the drag force, and yeah, it helped us solve our issue. So I hope that answers your question.
Yeah, that sounds really cool. That also reminds me, I was curious about like some classes or some activities you were a part of that really struck you as interesting and sort of like left an impression.
Um, I was briefly a part of a club last year. It was more for engineering students, but my focus aligns pretty closely with engineers. It was build your own race car. So that was really cool because I actually got to see the practical applications of math and physics and even software engineering, mechanical engineering, and really see how people actually use that in real life. And so um, I didn't really go through with the club for the rest of the year just because it was so demanding. But I remember them, starting to put the pieces together and using Python, generating code so that they could actually build their race car. So that was really cool and really stood out to me.
Speaking of sort of applications, I think you mentioned before that you studied sci or you study science, technology, and society to sort of like see how you can like apply your knowledge to the real world. I was just wondering, what are some applications right now that particularly appeal to you and sort of like why?
Yeah, for example, data science is a very big industry these days, or any sort of technology development. So I'm really drawn to data science because I feel like my background in math can help me build precise models or algorithms, while physics enhances my ability to understand systems and their underlying principles. So combining these would really help um, to do data science in industries like artificial intelligence or even renewable energy, financial technology, even the automotive industry, where complex systems need both deep technical knowledge but also creative thinking to succeed. So I know I mentioned a lot of different areas, but my focus particular is more so in artificial intelligence or with cars. I really liked the creative aspect in those industries, and especially artificial intelligence, which is so hot these days, and you don't know where it's going to be in 10 years, let alone like 5 years. So yeah, I'm definitely hoping to do a breakthrough after graduation.
And then, sort of to end off, I was just wondering if you had any pieces of advice, recommendations, suggestions, honestly, anything for students, but particularly young women who are interested in pursuing a STEM career in the future.
Yeah, definitely. I say do it. I say if you're really good at like biology or chemistry or math or physics and you really think you would I guess succeed if you go through with it, do it. Because when I was in grade 11 and 12, my mind, ironically, was set on medicine. So I really wanted to go into medicine and be a doctor and take that route, which I know a lot of girls at that age do want to also pursue because it's a very popular, and obviously it'll always be in demand, but it's a very popular pathway. However, I compared, literally compared my grades in biology and chemistry versus math and physics. And although I was good at both, and both were quite interesting, I was always better at math and physics. And it sort of like intrigued me just a little bit more. But honestly, even the sole fact that there's not as many women in math and physics than there are in chemistry and biology, that almost like made me just switch because I know a lot of women who are so good at math and physics or who are so good at like linear algebra or calculus, but simply because there's not enough representation, it could be very discouraging to pursue those paths. So my advice would be if you are really, really good at it, pursue your success and pursue that strength of yours. And I guess don't let um, I guess the fact that sometimes there could be more men than women or less diversity, don't let that hold you back because I know I would have regretted it if I didn't pursue physics.
Sounds good. Thank you so much for sharing your experience. It was absolutely phenomenal talking to you.
Of course, and thank you so much for having me.